All right. Welcome everybody to class 15 of our MUMPS course. So before we get started, I just need to discuss the whether we're gonna have class on some strategic days in December. The 24th is going to be the Christmas Eve, and then I believe the next class is on the 31st. And I was wondering if you guys prefer that we postpone class or move it to another day. And you guys just let me know what you think. Any opinions? I don't see anybody typing. Okay. Okay. Tony, postpone. Okay. Okay. All right. Well, I see. All right. Well, I suppose then we're gonna postpone. It looks like from what everybody's saying, it's let's go ahead and postpone it, and so essentially we are going to have classes 16 and 17 in December. So they will be on December 10th and 17th, and after that, our next class will be so we'll have 18, 19, and 20, and these will be in January. Okay. And I'm actually very happy to tell you guys that from your homework, you guys are doing really well. I've been very impressed by what I've been seeing. So we're gonna most of today's class we're gonna spend in homework review, because I believe the last homework was one of the most difficult I've ever assigned yet, and you know, most of you were almost at the finish line. You actually had very simple things that weren't working, and it was almost working. So we're gonna spend most of our time doing that, and then we are going to cover, time permitting, indirection and execute. They are both very simple concepts, but we'll see if we have time to cover them today. So. Um, Today, I'm going to start off with covering Linda's homework. And oh, well, I think we set these equal 1. And Linda's, there we go. All right, so we're gonna go ahead and run it and figure out where the problem is. But there are actually a couple of places where the routine isn't working. But at least right now I'm just showing you uh, a good idea of what it looks like. So the important things that we want to understand are, so we're gonna look at the enter label, and this is where all the pumpkin weights are entered. And then we have, if uh, if you select the number 2, which is the heaviest pumpkin, and if you select number 3, it will print the 3 heaviest pumpkins. And 4 is going to mean a quit. So far so good. That's the outline of the routine. We're going to see whether it actually works or not, and figure out and basically work our way backwards. So let's go ahead and print it. And so what I'm gonna do is, let's see, here's the print. Let's go ahead and run it. All right, so let's try the simplest thing that we could quit. All right, we couldn't even quit. So we're gonna troubleshoot the simplest thing first, which is, why is it not letting me quit? Now it tells me undefined local variable at the M source location. This is a trick I just showed Linda, and in GTM, your current position is always at the variable z position. So if I write $text of whatever is in z position, that gives me the actual line. I can also do write $text of at $z position, and we're gonna cover today on why that works, hopefully when we cover the indirection. But that gives me the same thing. So it's a shortcut. So it tells me here that either the variable m or mp is undefined. And let's see if we're still in the stack. Yes, we are. So I'm gonna go ahead write m. Yeah, that's undefined for sure. mp, both of them are undefined. Okay, so that's good. So let's go ahead and scroll back and take a look at the routine and figure out what these variables are. So one thing I would have liked Linda to do, and basically would have liked everybody else to do, is to tell me what the variables mean, because a variable name of m does not tell me anything. But it looks like that m actually is defined in enter. So we're gonna have to look and find out where m actually what m is. So let's go down to enter, and mp and mp are passed by reference. So we could see that p corresponds to pump, m corresponds to max, and mp corresponds to max pump. That's good. And then we move on, and oops, I figured out what the problem is. The problem is, and this is a problem that some experienced MUM programmers fall to, including me. The problem here is MUMPS internally, whenever you pass a parameter, it actually knews the parameter and defines it at a specific level. And so when you knew, what's happening here is that Linda is actually newing the variable again, in addition to what the compiler did. So usually when that happens, when you new something that has already been newed, the effect is the same as if you apply a kill to the variable, because you already knew that. So you're essentially telling the compiler, okay, new this again, I don't care about its previous value, and create a new copy for this specific level in the stack. And that doesn't really work. So if this is too complex for you to understand, let's just take this rule of thumb. The rule of thumb is, if your parameter is inside of parentheses, you do not have to new it again. And that's it. So you just don't have to worry about that. So let's take a look, and we're going to see here that it's pump, max, and max pump that actually have this issue. So let's actually go edit the routine. So actually, let me actually go back. Well, no, never mind. I'm gonna go over here and just emphasize what I mean again. Okay, so let me just rephrase this in another way. The reason m is not defined after after we're actually done is that, you know, when we enter it, it's still when we go down here, it actually when we new the variable, it breaks the link with the compiler link between this and this. So one of the first things we're gonna fix is we're gonna fix this. Oh, nope. I'm sorry. What was? I deleted something I should not have deleted. This needed to be newed. Okay, so that's good. So by the way, ZG ZL. All right. So let's go ahead and try to run it again and see whether the quit is gonna work or not. All right, so the quit did not work because we did not enter any pumpkins. But let's see if it's, we know this because the variables m and mp get defined here. So at this point, maybe we're just gonna comment out the zeroite and see if that just fixes it. Okay, that did fix it. So that's good. So now we know that the simplest thing actually works, which is the actual the quit. But I actually want to have that zeroite in there. But we're gonna get to it in a moment. So let's do the pumpkin weights right now. Let's see if we could enter these. Oh, so hitting enter does not do anything. I thought enter would make me quit or pre-prompt me. So I'll hit quit here. All right. So let's see if we could do 2. Okay, 2 does not work. 3 does not work. Does 4 work? 4 still works. Okay, so we're gonna have to figure out what the problem is with 2 and 3. Now, I was looking at this routine before the class, and I initially thought that the reason 2 and 3 didn't work is because the for loop did not start in the right place. But actually, I was wrong. But let's take a look at what the problem is here. So let's comment out the debug, but this time we're gonna make it more robust. So we're gonna say zeroite if $data of m. And then here we're gonna say zeroite if $data of mp. I misspelled it, right? mp here. Here we go. So that should not. So basically, the zeroite now is conditional, and it will not crash when I actually run it. So let's just verify that the m and mp actually come out, and see if that does the trick. Quit. All right, so I did not put a new line, but we could see that m is equal to 25 and mp is equal to 2. And that's pretty good. That's essentially we know that the variables are defined. So let's try number 2 and 3 again. See if they got magically fixed. Nope, they did not magically get fixed. So let's quit again. No, not this quit. This quit. Okay, so let's read this line carefully. So our problem, I think, when we select 2, this is what gets executed. If select equal 2, then it asks if mp equals 0, do no wait. And then there's another if. Now, I went over this with Linda, but it's a good educational experience. That there are three commands in MUMPS that have line scope. That's if, else, and for. Them having line scope means that if the command condition is true, it either runs or does not run the rest of the command. So what happened here is that MP was actually not MP was actually not zero here. It was actually 2. And therefore the rest of the line is not going to execute. Even the part that says if MP is greater than 0. Because if has a line scope, and once it found out that this condition isn't true, it's not going to run the rest. Same thing over here. If MP equals 0, same problem. So there are several ways to solve this, but I'm going to show you the way that I like the best. The way I would do it is I'm going to put a do and then 2 dots under it. And I'm going to say if MP equals 0, do no wait. And if MP greater than 0, do winner MP comma M. And we could delete this. So, and that's it. So at least we're gonna try it right now and see whether this actually works. So let's enter pumpkin weight 22, 33, and quit, and let's announce the winner. Okay, so it's working now. So now we know that we have to apply the same fix to option 3. So again, do, and Douglas was asking me when we were reviewing the homework, does it matter if there's a space between the dots? The answer is no. So I'm going to illustrate it with making 2 dots, but there is no space in between them. Again, if MP equals 0, do no wait. If MP greater than 0, print P. Huh? Oh, yes, you do. Absolutely. Thank you, Linda. All right. So that should do the trick. So let's try it now. So let's go ahead and enter the pumpkin weights. 23, 44, 67, 43, or 40. Well, that's okay. And then quit. Announce the winner. Good. I like that. How about print the 3 heaviest? Okay. Now it's telling me undefined local variable p. So we need to find out why is that. Again, I'm going to show you the trick I just showed you. So if you write $text of at $z position, it will tell you what the problem is. Okay, that's the actual part which actually tries to print it. So what's wrong with p? Now again, we're still in the stack. So I could just do zwrite p. And p is defined. Oh, we have a strange value in p down there, but we're not going to worry about that right now. So p is defined. So why is it saying undefined local variable p? Well, and this is actually the part that confused a lot of you in last class. And the thing is, there is a difference between passing by value and passing by reference. When you pass something by value and you don't have a dot, so before the p, therefore it's passing by value, what mumps does is that it looks for the actual variable p and looks to see if it has a value and then tries to pass that specific value to whatever variable that the receiving function has. Let's check. Let's quickly check to see if p does not have a value. So what Linda should have done here is instead of passing p itself, she should have passed the p array. And the way you do that in mumps is that you pass dot p. And that way you'll make sure that you're actually passing the p array. So down here, we're going to pass the p array. So now we're going to do .p. And let's just check quickly that print .p actually does something. So here is p. But we have a little problem here, just looking at the routine quickly. P does not mean anything here. Do you see it being used anywhere? It's not. So what we're going to do is we're just going to prove that the error exists, and we're going to continue on from there. So we're going to go ahead, enter the pumpkin weights, and let's just enter 2 pumpkins. Okay, it actually went down to the heavy, to 3. It did not cause an error, but nothing happened. And again, go back to my instinct. When nothing happens and you passed an array, it means your for loop is messed up. So that's usually what happens. But let's take, we already know that's actually not the for loop that's messed up, but the variable that the for loop is operating on. And my cursor is not moving. What happened? Uh-oh is right. Let me just make sure that my computer is still working. Yes, my computer is still working. Let me see if I could... I don't know. Let me just see if I could just load. Yep, I can still connect to the internet. Okay, let's try escape. Oh, no. Oh. Oh, here, it's moving again. Oh, that's the actual screen. Okay, that's the actual screen. It's moving. So it's mumps that got frozen. So if we know that the screen is working. Oh, here we go. Well, I'm not seeing that anything is happening, but looks like the screen is still working because I could move my cursor. Oh, here we go again. We either have a delay or something. I'm not sure. Escape. Okay, I'm gonna log in elsewhere and just gonna try to kill off this session. So let me see. Just kill off the mumps session. We don't want it anyway. Okay, so I'm supposed to have killed it now. Okay, there's no more mumps according to everything that I know. Okay. Okay, guys, sorry. Looks like I have to kill the screen session, so you're gonna have to rejoin in. So let me go ahead and kill it. You can't detach, right? Yeah, that means I have to apply some magic here. Kill all screen. Okay, you should have detached now. Let me just make sure that I don't have any more screen before I start it again. I see that there are still a few screen sessions, so let me just make sure I kill those off too. All right, so I think that should be it. Okay, good. I started a new screen session. You guys could go ahead and join in. All right, back to Linda's routine. And so now, by the way, these bugs are actually somewhat common when you actually see real mumps code. We're now fixing pretty much real bugs, and we need to figure out. We need to get in the mind of the programmer. What did the programmer actually intend to pass to that subroutine? And when we're reading this, it looks like he or she. Sorry, I'm being a male chauvinist here. He or she is newing the variable pumpkin and result, and therefore we should not worry about those. These are internal to here. So let's look. Result, pumpkin, pumpkin. But look at this. There's one variable here that's this he or she seems to operate on, and it's pump. Therefore, my best guess is that the programmer really does not want to be this to be P. She wants it to be pump for pumpkin. All right. So that's our best guess. So when the programmer passes the variable P here, and it's passed by reference, mumps does an implicit new here for this variable and changes its memory location to point at the original variable, which contains an array. And only does that because it's passing it by reference. If it's passing it by value, it's just going to copy the contents of the variable P, the new variable here, and just set it to that single value. All right. So I think now that the routine should work. There you go. We got the winner and the 3 heaviest pumpkins. All right, that worked. That really worked. That's pretty cool. And we quit. Okay, very good. So last thing left for us to fix is we need to remove these variables, the debug. So I personally usually leave the debugs in for the next programmer who's gonna be reading my code. So I just comment them out because somebody down the road might have to debug my code. So okay, that's right. We do have leakage, but I'm not there yet. I'm gonna show them a tool to check for leakage. All right, and I forgot press quit. Announce winner. 3. Uh-oh. Okay, we discovered the bug, but that's okay. So, question, but Linda has a good point. How do you check for leakage? So let's see, write our symbol table. We're gonna kill everything. Make sure it's empty. You could, and now run the routine. And Z-write again. Now you could see that Linda has leakage in several variables. And so we could fix them one by one. Now, this is a good point, but you guys must be asking yourself, does every programmer in Vista actually have to do this and check this? Isn't it too onerous? It is a bit onerous. We have another tool. I'll show you that other tool. It's called Xindex, and people who have worked in the Vista world are familiar with it. What's your routine's name, Linda, again? Z03. Yep, okay. Here you go. Now, this one, you're going to say yes, but here we're going to just say summary only, and no, and we're going to go ahead and print it. All right, so Xindex usually has to run on all routines before they get certified to run on Vista. And so the Xindex is telling you that per Vista standards and conventions, all reads have to have timeouts. Therefore, it's warning you about that. It's also warning that there's a blank at the end of the line, which is a stupid warning, but I guess people really wanted to keep their space small. Now, so the other thing that Xindex does, and we're going to have to look at it, any variable that has two little arrows next to it, it means that this variable can possibly leak. So when I'm programming in Vista, Dr. Joel Ivy, who retired recently, made a tool that wraps around Xindex and extracts this information. And every single time you save your routine in the Eclipse editor, or for my case, I actually integrate it inside of Vim, the editor I use. Every time you save the routine, it actually tells you, oops, those variables leak out. Make sure you check them out. So here it tells us what the variables that leak out are, and I pretty much, I usually make sure I keep saving my routine until I make sure that nothing ever leaks out. So let's go ahead and figure out what these variables are. So as usual, when you're programming, you need to have a pen and paper with you and type and write ENT, M, MEN, and P. Okay. Set is equal 1. Let's just do that. Okay. So let's figure out their context. So where does P first show up? P usually first shows up here. So, and M shows up here first. So, it's not a bad idea to new P and M and put in a comment P equal pumpkin weights array. M is, I believe it's the maximum weight, right? All right. Oh, whoops, I don't know what I did. Maximum weight. All right, so that takes care of the variables P and M. Now we have the variables ENT and MEN. So let's figure out where these are. The top for loop? Oh, okay. Okay, so this one is just for the menu, right? And you don't really need it for anything else. I don't think so. Doesn't look like it. So what we're gonna do in here then, we're gonna say new MEN, and we don't have to set it because the for loop does the setting. Now, there is a tiny problem, and somebody could actually exploit it in some of your code. And the fact is, MEN is one step one. That, well, you could do it that way. You're not using MEN for anything. But the problem could be that somebody. Oh, screen is terminating? Hold on a moment, guys. What happened? That does not make any freaking sense. Are you seeing anything, Linda? On your screen? My thing just stopped working all of a sudden. Oh my god, here we go again.
I still see you tapping along.
Okay, you do see me tapping along?
I do.
Okay, I'm not sure what happened.
Now I know. Oh, that's moving.
It said copy mode. Okay, I don't know what happened to my own personal screen because it got oh, here we go. I don't know what's it doing, but oh, okay. STTY reset. Oh no, the STTY sane and the system reset. Okay, that's okay. My up arrow isn't working, but that's not the biggest problem in the world. All right, we're back here. Oh, yeah, my up arrow really isn't working. What does it do? It doesn't do anything, does it? Okay. It's not even quitting, is it? uh, Control A detach. Control A detach, please. Control A detach. It's not doing anything in my thing. Okay. Well, I don't know, guys. Looks like we're gonna have to do this again. Okay. Give me a moment while I start the screen again, but I need to make sure my up arrow works. I'm actually gonna just log out of forum and go back in, and I'm gonna start the screen. The screen has started. You could now join me again. Oh yeah, sorry, that's the wrong account. Sudo su dash. Okay, so we're back here. I can't even remember what we were doing last.
We were looking at the four.
Oh yeah, that's right. Okay, that's right. Also, the problem here where it says the menu is one step one is that MUMPS, as with every other language, does not have an infinite buffer for numbers. So it's possible that menu could reach whenever you go in a loop. You could keep go. It could MEN could go up to a number that MUMPS does not support. So what I would suggest is you could do new man, and we honestly, I don't think we don't use men for anything, do we, Linda? No? Okay, actually, we don't even need it. We could just put the 4 with 2 spaces. And we don't have to have any variable that we're incrementing every time we do a for. So let's go down here, and for ent equal 1 step 1. Are we using ent for anything here? Okay, again, same fix then. So for 2 spaces do. All right, so and oh, we must have some variables leaking from before, I think. Or we didn't save. Some of the changes did not save. Okay, let's go ahead and reapply them. Old habits die hard. Although the colors are nice. Set DZ equal 1. And all right, as usual, I'm not gonna work too much on the comments. I'm gonna just say a new P and M. Kill the Z03CL14A. Enter pumpkin weights. I'll quit. Oh, because of that bug. That's okay. What did I do? Oh yeah, because of that bug. That's all right. Zeroite. So we only have one variable that's leaking now, and I'm not sure why. But MP3. Let's run it again. Quit, kill, run, quit, 2. Oh. Write $text at $z position, and if MP is greater than 1, it says undefined.
Because you muted it.
Ah, that's right. Hold on. I know what the problem is. The perils of fixing routines where you didn't study them long enough. You're right. Once I knew M over here, what happens is that its value disappears. And so that will happen also with P for that matter.
You can new MP there too.
So I think what we want to do, F1 delete, escape delete, sorry. And we're just going to new them at the top. I did this again. Sorry. Oh. Here we go. Here we go. It's working.
Oh, his cell is bricked. It's broken right now. He's gonna get it fixed in the morning.
All right. So we have MP is leaking. So we need to figure out MP is one of the variables here. So again, we go ahead and define it here. MP. And apparently X index did not catch that. So okay. Okay, guys, I just have to tell you, I'm tired of this routine. So that's long enough to spend on one routine. Let's cover Tony's routine now. because he has a very good question inside his routine. So Tony's routine for reference is this. So it actually breaks in a specific place, and I'm trying to find where it was. We're gonna find it in a moment. Let's just go ahead and run it. All right, so all right. He says label expected in this context at M source location menu plus 35. So again, same trick, write $text at $Z position. Okay, so we covered extrinsics in the last class, and what Tony is doing here is not valid mumps code. So my boss was basically telling me I should not have taught you guys extrinsics in the same class I taught you passing by reference because it's too much to absorb. And extrinsics are really tricky. I'm tending now to agree with him. But so let's talk about extrinsics a bit more. Extrinsics are essentially you simulating a do, but in an expression in mumps, and therefore, let's cover the important point here. An extrinsic is an expression; it's not a statement. That means that an extrinsic can be an argument for a set command. It can be an argument for a write. So I'll give you an example. When I want to uppercase something in an extrinsic, you could do write up caret xlf str, and then the actual value. So you want to say we want to uppercase ABC. We're gonna make them uppercase ABC. You see that? So now the important thing to understand here that yes, this is in fact executing something like a do and going up to different levels of the stack, but it's doing that as an expression and giving you a value back. And so this is the big difference about with it and with a do. And so an extrinsic will always give you a return value. And so we can use it in writes. We can use it in set x equal to this, for example. But what we can't do is we cannot use it as an argument for a do command, because the argument for a do command is a routine. And when you have $, it means that you don't have a routine anymore. You have something that looks like a routine, but it's really an expression. So if you don't understand this explanation, the simpler explanation which you have to file in your head is that it's an expression, and therefore it needs to get set to a value somewhere, or either written out or read or set. An expression is like this. This is an expression, and this does the same thing. So going back a little bit and going over Tony's routine, we have to fix this. And the big thing is that he created an extrinsic function here. It says GTWT, it means probably get weight. So I'm thinking that it must return a value, but I don't know what it is. So we're gonna take a look at the routine and see what values it's supposed to return. So Z02 homework 14. All right. So here it is. So do get weight of Z02 homework 14. Now, one thing that you guys should notice is that this is the current routine we're in, and if you're inside the current routine, you do not need to put the up caret, so we could just abbreviate it to this. So now we have to figure out what's the return value from get weight. So let's keep going. Okay. So normally it's a very good practice for a programmer when I read the label to tell me what are the parameters, which he's telling me here, but he's not telling me what's returned. So I'm gonna have to keep looking, keep going down. Okay. Looks like he's trying to pass the array back. And this is a good point. And in MUMPS, you cannot pass back an array, unfortunately. When you quit pump, it only checks the actual value of the top level variable called PUMP and nothing under it. It says it's like pass by value but in reverse. And therefore, when you quit with pump, that does not work. So, Tony, does that make sense? Or do you want me to go step through it? I'm seeing if he's typing. So how do you do it if you cannot pass back an array? Okay, let me show you. So you actually did it correctly when you did the pass by reference. So let's take a look back. So you see you're passing the weight array by reference here. Therefore, when you pass it down, weight becomes pump, and you set the values into pump, and therefore you're gonna get all your variables back in the weight array up top. Does that make sense? No, it does not make sense. Okay. Yes, exactly. Okay, let me show you how we could make it work. So the first thing is we can only pass back a scalar value, which means we can only pass back the actual value of pump itself. So we cannot pass back an array. So we're gonna change this to be just a quit. And we're gonna go back up, and instead of do $, we're gonna just say remove the $, because it's not an extrinsic anymore. And here it's gonna just pass the current values. And so remember, since you're passing weight by reference, and weight becomes pumpkin or PUMP, therefore whatever you set to pumpkin down here gets returned back when the function ceases execution. And where is it? Oh, here it is. Gets returned back, and weight now contains the entire array. That's how you pass an array back in MUMPS, is doing it by a reference variable. All right, let's step through it because I see that you're still a little bit confused. So, so. Okay, so let's enter the weights of the pumpkins. All right, I'm gonna do Control C here and look at our stack. So we are at, let's write dollar text of this one. This is the weight. This is the array that lets us read stuff in, and this is the actual read. And so I'm gonna go ahead and z-step into it now. So 5. Hold on, I actually need to set the z-step. Step into. All right. Good. Enter weight 2, read x. Let's put 75. Z-step into. Z-step, and so on. This all makes sense. All right, it's finished, but we're gonna quit. We're not gonna enter anything here. So we're gonna go ahead and z-write PUMP. So you could see that this is what it is right now. Here's the other thing. Now z-write WT. Now, and we said that GTM unfortunately has an unfortunate tendency with its notations, but you could see down here when you do a general z-write that it tells you that weight is the same thing as pumpkin inside the symbol table. So it's gonna say, so we're gonna do z-step into, and we're gonna just hit, I don't know how you quit. You quit. All right. Here we go. All right, so this is important now. So let's look at the line we previously executed. So that's menu plus 35. So dollar text of menu plus 35. And you see it's get weight. So now let's take a look and see what weight is. Weight is essentially what pumpkin used to be. So z-write pump. It's not defined anymore because we're outside of that context. Count. Good. Good. Okay. This is good. So Tony, does it make sense now? Okay, good. Good. All right. Let's just Z continue and go ahead and type print. And here we go. We got the results. And we could do S to are you sure? Type yes. All right, we changed everything. So now it's working properly. Okay, good job. So it's working properly. So I have a feeling that I need to cover extrinsics one more time because I think you guys are still confused by it. And maybe it's not time for this class, but maybe I'll cover it next class. So, okay. Let me see what's the other homework I wanted to cover. I had, I believe it's Manohar's homework that I wanted to cover. Okay. So I'm just getting myself acquainted with what the actual issue is here. And I can't remember what was the actual issue we're gonna cover here, but let's run it and figure out what I was trying to remember that I had to run. All right. All right, display all the pumpkins in reverse weight order. Okay, I must have fixed that routine and I don't remember what I fixed in it anymore. I remember I responded to Manohar in an email telling him what I fixed, but I can't remember anymore. Oh, it was the pass by reference. Okay, that sounds about right. Oh yes, I remember now. Okay, so Manohar, just like Linda had, she essentially he had do display of pumpkin, and without the dot, and therefore it failed. And let's figure out. So and here we go. So we get undefined in this line. And if we Z-write pumpkin, we see that pumpkin is indeed defined. But remember, when you're passing something by value, the only thing you're passing is the top level. So let's figure out, for ourselves if the top level is defined. Top level is not defined. So therefore, when you try to pass something by value, it does not exist. So instead, you need to pass a reference to keep a link with the original variable so that the array could be passed in. All right, and now that should actually do the trick. Here we go. And oh yeah, we saw that it was working, so we don't need to show that again. So, but I just want to mention to Manohar that his routine, I think, still leaks a lot. So let's kill everything and run it. All right, so Z-write. Okay, well, apparently it doesn't leak that much. Let's see what Xindex thinks. And I'm trying to remember what was the actual routine we wanted to look at. Z04ASN. Print more, yes, yes, no. Okay, here we go. So it's telling me that the variable I and the variable weight, just like we detected, are the ones leaking. So we're going to have to fix that. But rather than fixing it here, I'm going to leave this as an exercise for Manohar right now. Okay, so let's move on to our class material. And today's class is going to be, I'm hoping, the actual concepts are simple, but their implementation is somewhat difficult. We're going to cover the concepts, and essentially, you're essentially going to have to learn when you're seeing mumps code that does stuff like that, that this is what's it doing, and you'll need to learn from the context that this is what's going on. So let me cover. So the two things we're going to cover today is the @ sign for indirection and the execute command. So let's cover indirection. So actually, I believe that this is actually the very last thing that's commonly used in mumps that I actually need to teach you, because after that in our class we are going to be covering odds and ends. That if you read VISTA code with all that you learned, you're going to be able to understand about 95% of it, because that's so far what I taught you in class is essentially 95% of the code that you're going to see in VISTA. This is the last part that's missing from that 95%, and I'm going to teach it to you today. So indirection is a tricky concept. Why is it tricky? Essentially, it says treat the contents of the variable indirected as a variable. Okay, that sounds very creepy and ununderstandable. Let's figure this out. So let's set x equal to 5. That's easy. Write x. Okay, good. That's easy. Nothing hard here. Set y equal to x. Write y. Okay, nothing difficult here. But look at this. Okay, guys, we could actually go home now. That's all there is to know about indirection. That's it. It's when you see it in my real mumps code, it gets really tricky. But all it is that it says, I want you to treat the contents of the variable as if they are a variable. So it's saying here that what's the contents of y? The content of y is x. I don't want you to treat x like here, like it's a string. Whoops, let's remove this. So here x is a string. I want you to treat the contents of x as if they are a variable. So what's at y? It's x, and x is a variable. And what's x when it's a variable? It's 5. So you could see it's tricky, but it's really simple. So this will explain to you something we have been doing for a long time now with $text. Remember, I keep telling you when we run a routine. So let's do z break up caret xup and do up caret xup. All right. And I told you, when you're troubleshooting, you could just write $text of at $z position. And you just followed my instructions, hopefully without thinking too much about that @ sign. Now it's time for you to understand what that @ sign means. Let's look at z position here. Okay, good. So if I write $text without the @ sign, I'm just going to put z position. Guess what's going to tell you? It's going to tell you it's an invalid argument to the $text function. So what does the @ do? It says treat the contents of the variable as if they are it's a variable itself. Except in this case, it's not the true definition. So the definition I gave you was wrong, actually. So the definition I gave you was wrong, because the contents of $z position are not a variable. The contents are an argument to $text. So convert string contents of variable to appropriate argument to current command. This is a more accurate definition because we just saw that when we did write at when we did write at y, that actually worked. It was the contents of a variable. But with dollar text, that does not make any sense. So it's essentially saying write dollar text of $z position is not going to work. If we do at, it's going to work now. So an easy way to simulate the at sign without getting crazy is the following. So you could do the following. You could write dollar text of make a string. So you could say, we said it says convert string content. So I actually could just type the actual string in there. And the string here is xup plus 28 upcaret xup. It's not going to work. But guess what happens when I put the at sign? It works. Okay, another example. Another common example where we use the at sign a lot is with the do command, where sometimes, we look up in a FileMan file what routine to run, like in the remote procedure broker file, and then run that command. So I'll show you how it works. So remember that FileMan, to enter FileMan, we needed to run p upcaret di like this. So that takes us into FileMan. Okay. So let's say that there is the user has to give me what entry point they have to use, or let's say that the user has to give me or the entry point is stored in a file. So I get back a string. So let's say set x equal p upcaret di. Can I say do x? I can't. I can. And that exactly worked. Do at x will do the trick. Okay. There's one more commonly used form of the at sign, and it's one of the trickier ones. So let me show it to you. So let's say I'm reading a file that has a symbol table or global file entries, and one of the global file entries looks like this: kban, etc. equal 111222333. Okay, so I read this from a file. This is common enough inside of Vista. Not that rare. It should be rarer, but it's not that rare. So when you read it from a file, let's say it's inside of X. Now, normally you would type something like set upcaret kban etc equal to 111222333. All right, but that's not what we're going to hear here. Let's look at X. So we could type set at X, and that works. All right, that's all I want to say about the at sign. It's really easy to understand, except that you just have to know that all it does in every context is that it changes an argument from a string to an actual argument. Because can I say set x? It's not going to work. I can't. But I can say set the contents of x, and that will work. And again, simulation. If you want to debug this, you could do it this way. You could say, since x is actually a string, and remember, everything in MUMPS, when stored, is a string. So this is not going to work. You could put the at sign, and it does the exact same thing. Okay, that's all I'm gonna say about the at, and maybe we're gonna see it in some of the routines that we're gonna take a look at. So the next thing I want to show you guys today is the execute command. So the execute, all right. Actually, hold on. This is not exactly right. Run mumps code in a string as if you just typed it in. So you could say set x equal right 1, 2, 3, 4, 5. Now you might. So the way you're gonna run this is execute x, and look what just happened. Of course, what confuses people is this looks so much like the at sign, but can we try right at x? Nope. So, by the way, executes abbreviation is x. So we could have written the above line as xx. And we could simulate a command prompt inside of mumps. So we could say for right read x x x. And look, we just have a new command prompt. Oh, except we need the new line. So let's try fixing that. Read x read x and execute x and then write new line. Okay, well, we still need another new line, but you get the idea. So just in case you did not get this, let me explain it. So this is an infinite for loop. This is the thing that writes the command line, and then this reads the variable x, and then this is a command, not a variable. So this x, it says execute the variable x, but it just looks funny when it says read xxx. Okay, how often is execute used in mumps code? Pretty rarely. The only packages that do execute are essentially the infrastructure packages in Vista. So when fileman needs to pick up some data in a line that a programmer wrote, and it takes it and then executes it. Or sometimes the remote procedure broker might do the same thing with something called the rule inside the menu option. And it's not that common basically, but you should just know that this is what execute does. Okay. That's all I have to cover for this class. Now I am going to assign you a very interesting homework. Um, this homework is time permitting. I'm trying to figure out. I sort of want to do a homework where you actually read some Vista code, and then we go through it together and figure out what the Vista code does. That's really important because that's pretty much what if you don't write any mumps code in your career, you sure as hell will be reading some. And that's really important that you're able to read some Vista code. So that's the very first thing I want to assign you. And then the next thing I want to assign you is basically doing a semester project. And I guess you guys could work together to see what semester projects that you want to do. Some of the ideas I had, I talked with Tony about something that he wants to do that has to do with patient data import from outside of Vista. Um, I think some other folks are interested in SNOMED, and so we could work on importing SNOMED concepts into Vista. And so we could work on these things and decide on who wants to tackle what. And I'll be available to help you with your project. But for this homework, and this homework will be due, let's say, in should it be next week or the week after that? I'm not sure. Let me. I'll give you a couple of weeks for this one. I want you to read a specific VA Vista routines and figure out what they do. You're going to have to essentially comment the lines and figure out what they do. So here are the routines, and you guys could pick. If you have a routine in Vista you're really interested in, you could go ahead and do it. But here are my suggestions. I spent a good amount of time figuring out easy enough routines um, to actually figure out. So this is one. So this is lab. Top to slow up caret. LRVER. This is another. That's another. That's another one. Oh, so this one is entry, full, abstract. So mag is imaging. Mag QBJH. And the next one is ping up caret PSSHRIT. Actually, it's ping to SMSGDWN of PSSHRIT and EN up caret lex code. So let me see how many are these. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's perfect. So I want you guys go ahead and you could either pick one right now or later, or you could pick one on your own, something that you personally want to look at yourself. So anybody who wants to call dibs on one of these? Okay, good question. They're all located in vForum, so you're just gonna be you're gonna do your homework on vForum. Or if you have your own Vista environment, you could actually take a look at them over there. Okay. Anybody wants to pick anything? So there you have stuff that has to do with. You have some stuff that has to do with pharmacy, lexicon, imaging, and lab. Yes, you're not gonna be writing anything on V Forum. You're just gonna be reading the routine. You could just copy paste it in your own into a word processor or whatever, and just type on it to explain what it does. Okay, so Alice chose the lexicon. Okay, so Tom will do the ping. Okay, it's not. So Tom will take the ping in the pharmacy routine. Okay, so Tony. She'll take what's left. Fourth one. What's the fourth one? It's the creatinine clearance. All right. Okay. Uh, no, Manoj took that one already. Oops. First one gets dibs. All right. This one is Manoj. Oh, okay. So Manohar is gonna take the lab. Okay. So this is Manohar. Analyst Tom. Okay. All righty. You'll take lab. So let's see. You have LRVER that's left. So you're gonna take. So Jignesh will take LRVER. All right. So Linda, you just have imaging left. I'm sorry. Okay. So I'll see you guys next week then. That'll be it.